Okay, so let us continue the lesson. So let me recap a little bit what we learned. So the topic was the chain rule, and then if you remember, this is the previous lesson that you also learned in Math 3C together with these three formulas. What we did last time, we added one generic formula to the list, which is actually one of the most important formulas in the topic of derivative and differentiation. So let me just tell you what happens. So if you have two functions composed, f after g, we discussed about that, and if you want to take the derivative of this, which I already talked about what the meaning is, this means that you go to f, take x off, replace x with g of x, you get a new expression or a new function, you differentiate that new expression. So here you first replace and then differentiate. The answer turns out to be the product of this function, which is called the outer function, multiplied by the product of this function, which is the inner function. For the inner function, you don't need to be very cautious. That is just g prime of x as usual. But this one is not f prime of x, is f prime calculated at the inner function g of x. Okay? So when I write the chain rule in this way, this is also good to understand that it matters if you put prime there, up there, or you put the prime on f. These are not equal things, unless coincidentally this turns out to be 1. If the derivative of the inner function is 1, these two symbols are identical. Otherwise, they are related by this, what we call the chain rule. Okay? So as we told before, there is no difference between f of x prime and f prime of x, so it doesn't matter, because the x is the inner function and the derivative of x is 1, so there is no difference between them whatsoever. And then we solved some problems, and I told you that understanding it is one thing, doing it faster and efficient is another thing. Okay, so we discussed about understanding it deeper, but today my main focus was being able to do it more efficiently in the way that I will describe it. But if you don't mind, let me solve one of these problems. This is problem 3134, yes? Let me solve this first part only, using what we learned yesterday, and then I tell you what to do from now on to do it faster, and then we use this method that I will describe for the other one. Of course, this is essentially the same thing. I'm not inventing something new, but I'm trying to teach you a way that if you think in that way, it becomes faster and more efficient, especially for more complicated functions. Okay, so let me go to this problem, which is given in your book. I just solved the first part now. So f of x is what? Is 7x plus 11. Yes, is that right? Plus 11 to the power of 5. And if you don't mind to stick to my previous notation, because f in the book is used for the inner function, okay? Of course, this is the way that you usually get. But for understanding, let me change the name to h as I used before, okay? And I want to differentiate h. Okay, I want to do it exactly as I did before. So I have to ask myself, is it possible to use my table directly for differentiating this? The answer is no, because this function is not in this form in my table. So then I have to find another way. One way we have learned so far is the method of this chain rule. So a chain rule needs inner function and outer function. Okay, so you have to guess the outer function. You have to guess the inner function. Your goal is that if you compose f after g, it becomes this function. This is one criterion. The other criterion is each one of these functions you can differentiate using your table. So it is not only to compose them and it becomes this. I want you to write two functions that you not only compose and the composition is this, but also each one of them you can differentiate using the information on that list. Okay, but that's extremely simple. So what is the inner function here?
7x plus 11.
7x plus 11. And what is the outer function?
X power 5.
X to the power of 5. And as I told you that when you found your inner function, you just differentiated, end of story for that. But when you found your other function, you not only differentiated, but that is, I told you, it's not the end of the story. The end of the story is to calculate f prime of g of x, which means what? Which means replace x with g of x. Okay, so 5 is 5. Instead of x, I put g of x. And this will be the end of the story for f as well. And then your question mark, which is the derivative of h, is the product of these two boxes. So this multiplied by 7 is 35. So the answer is 35, 7x plus 11 to the power of 4, and that is what you're supposed to do. Okay, so that is exactly what we did before, but let us do it faster. The way that I want to do it from now on, I will ask myself, so this is the way we want to do. I want to just name g of x to be u. Okay, so then it becomes what? So it becomes u prime. So you see, this becomes f of u totally prime is equal to f prime of u. You see the difference between f u prime and f prime of u, they are not the same. They differ by a factor of u prime. So this is also a good way of visualizing the chain rule, but be careful, u is a function of x, which of course can be x itself, because u equals to x is also a function of x. So you see, I have done nothing. I introduce a name for g of x to be able to write it in a more compact way. Okay, and this is the only factor that you have to be careful. So when I want to solve this from scratch, of course this is the correct way of doing it, but I will not do it because it takes a long time. So I ask myself, what is my u in this problem? Okay, what do I mean by that? It means I choose a u in a way that after that is done, so let me explain. For example, in this problem, in my head, I don't need even to write it down. I take this to be u. Is it a good choice? I would say yes, because if I take this to be u, the answer becomes u to the power of 5. U to the power of 5 is comparable to x to the power of 5. Do I know how to differentiate x to power 5? Yes, the answer is 5x to the 4th. The derivative of u to the power of 5 will follow the same rule, meaning it becomes this, but the only thing that you need to remember is to multiply it by u prime. Yes? So that is the only thing that you need to remember. Okay, so let us just do it again. So if I want to differentiate that, I realize that the information in the table directly is not enough, so I need to think about the chain rule. Either you do it in this way, which is good to understand, but it is not good to doing things efficiently. So this is why from now on I want to skip this long method. And I would say that, okay, let us take something to be u, so that after that I know how to differentiate. Okay? So I didn't have that much choices here. This is a very simple problem. So I take this u in my head. Is it a good choice? Yes, because it becomes u to the power of 5. Can I differentiate u to power 5 according to the rule that I learned? Yes, because I know x to power 5. The rule for x to power 5 is 5x to the 4. So the only difference is that for u to power 5, the rule is the same as if u is x, but then the only thing that matters is to multiply by an extra u prime. Yes? That is, if you think in that way, it becomes much faster. So what I do, if I want to differentiate this, I take this u in my head, and then I differentiate u power 5, which is 5 u to power 4, but u is this guy. Okay, the only thing that to the power of 4, the only thing that you shouldn't forget is to multiply. The problem is not finished here. You have to multiply by u prime. So what is u? U is this, and then you have to differentiate that one. Okay, so I prefer to do it like this instead of writing so many things. But the process is not finished. The process is finished when there is no prime left. So you have to continue. So this means that you have to do some copy and pasting. And then can I differentiate this one? I can ignore this. I want to concentrate on differentiating this. The answer is 7. And then I multiply them. It becomes the answer I got before. So this is the this is the way that I want to proceed from now on. So for simple problems, it doesn't differ that much, but you will see that if I have the composition of more than 2 functions, it really matters if you do it the other way around. Okay? Is that understandable? Okay, so let us go to the next problem. I will do that one as well. So here, I don't need to change the name anymore. Okay, so I will stick to the name f again. So f is the square root of 3x minus 4. So f of x is the square root of 3x minus 4. So the first thing, let us review. Is the information directly in the table enough for me? No, because I know the derivative of the square root of x. It is similar to that, but it's not exactly that expression, and mathematics is unforgivable. Everything should 100% match. Okay, so even a slight difference, it doesn't mean that I can follow exactly the same rule. No. If it were x exactly, yes, the derivative is this one. But for this one, what should I do? I understand that I have to choose use the chain rule. So what do you think? You need to think about an expression to give the role of u2. So which expression do you think is good? You need to have intuition. So what should you, yes? 3x minus 4. Why this is a good choice? So in a scratch paper, you want to see why this is a good choice. Because if I take this u, then it becomes the square root of u. Do I know how to differentiate this? I would say yes, because I have it in my table, not for u, for x. But I learned the only difference between u and x is a matter of multiplication by an extra u prime. So I will follow the same rule as if u is x. For x, it was finished here. For u, it is not finished here. You have to multiply by u prime. Is that clear? Okay, so I follow. So this becomes, so the derivative of f becomes 1 over 2 square root of u, but don't write u and then replace it. Just put it in your head. So u is 3x minus 4. But the problem is not finished yet. You have to multiply by the derivative of what you called u. And the process is finished only if there is no primes left. So it means it's not finished yet. So this means that I have to copy and paste what does not include prime, and then multiply by the next step. So what happens? It becomes just simply 3. And I prefer to write it more compactly. It's not an obligation, of course, but let us write it like this. That's the end of the story. Is that clear? And somehow you felt a little bit of why chain rule is a good name, because you differentiated the first part, you just wanted to relax, but another loop of chain came in, so you have to differentiate that one as well. So if you have the composition of 3 functions, 4 functions, whenever you want to relax, another loop comes in, so you have to do this one. So chain rule is a good name, you will see that. Okay, I just want to wait for you to do it in the fast, more efficient way. So when I give this in the exam, if the answer is required, I don't care, I just care about the final answer. But if you're supposed to show the process, you have to show the process, okay? So just do that. Yes. So I want to wait for you so that you can solve the other two yourself in this way, and then we go to some other problems in the book. So there are some good problems. We will reach to them, okay? Okay, so you just do part C and part D using the idea of taking something to be U. So the chain rule is very important. Don't think this is the only exercises. When we go forward and we learn more new rules, every time you will get a lot of exercises which is involved with the chain rule. So if you don't understand the chain rule, more or less you will not understand other parts very efficiently. Okay, I think this is very simple, so let us not waste so much time. So which choice is a suitable choice for you in this problem?
5x plus 3.
5x plus 3. So, but you just do it in your head, okay? I'm just explaining this because I want you to understand. But this is just you. And then, is it a good choice? Yes. Why? Because if you choose this in a scratch word, you see you e to power u. Do I know the rule for the derivative of e to power u? Yes. Why? Because you can pretend that u is x. If u is x, you have it in the table. So what's the answer? It's e to power u itself. But in the case that you have x that was finalized, and then here you have to multiply by u prime. So these formulas, I would say them chain rule version of the table. You don't have them in the formula sheet, okay? So you have only access to those. So, but using those information to find this is not hard, because you compare e to power u with e to power x. Up to here is the same rule. But now, because this is u, you have to remember to multiply by u primes. That's always the case. Okay, so then if I want to differentiate that, so what should I do? E to power u, it is here, so it becomes e to power u again. But don't write u, write just 5x plus 3. But the problem is not finished. You have to multiply by the derivative of u. And the derivative of this is what? 5. That's it. So that's the answer. For this one, of course, you can expand. That is also acceptable if I haven't mentioned using the chain rule. But let us use the chain rule. But what is my choice for you here? Not too many options. What is that? Let us take this one to be u. And then, is it good? Yes, because I will have u squared. Do I know how to differentiate u squared? The answer is yes, because I know how to differentiate x squared. U squared will follow the same rule, which is 2u, but then you have to remember to multiply by u prime. So then I will do the same thing. So f prime of x is equal to 2u, which is 2x squared minus 1, but it is not finished, multiplied by u, whatever it is, prime. And then you have to do it until you do not have any primes left. So what is the derivative? 2x. And then, so if you don't mind, let me write it in 2 steps. You can do a lot of things in your head. Okay, so that is the answer, but I prefer to multiply them, so it becomes 4x, x squared minus, that's the answer. Okay, good. Questions? So these were level 1. Let us go to level 2 problems here. So I want to wait for you a little bit so that you can manage this problem. So be ready. Sometimes they ask you questions, just give you a function and ask you to differentiate. Sometimes they ask you more conceptual questions, as we solved in the previous lesson. Do you remember the last 2 examples? I told you there are level 3 problems, but they are more conceptual problems. Okay, so I want to wait for you, okay? So I want to wait for you to read the problem yourself. So a composition function h following this. Determine h of x if g of x is this and f of x is this, and finally determine h prime of x, h prime of 2. Yes, unfortunately I forgot to record this last part, but anyway. So this is the method the book wants us to do, but I want you to understand. If there is something ambiguous here, please let me know. What I did, I asked myself, I want to calculate h prime at 2. in order to calculate the derivative at a number, first I need to know my derivative. My function is this, so my derivative becomes the derivative of this function. So the derivative of this function is written as a chain rule, so I followed that rule. And then I replace x with 2. Then I have some ingredients to fill up, which is easy. At this stage, again, I go back to what I need. I generate what I need, little by little, yes? So first I generated this. I got that number. Then I generated that, I got 6, but this is not done because this is f prime of 6. Then I generated that one, it becomes 12, and then I'm off. It's important to know both methods. Okay, so let us now go. I want to wait for you now so that you can solve problem 3137. Let us just do it. You can do the other ones yourself when you have enough time. But let us do this part B. I want to wait for you, okay? 3137 part B. Very simple problem. Of course, this is level 2, but it is very simple. Okay, did you get it? I think the answer is very simple. So this is why I don't want to spend so much time. Interesting questions are coming. What is the answer? Yes? 1/2, yes. The correct answer is 1/2. So let us analyze the problem. You see a function is given. You want to calculate the derivative of the function at a given number 1. So you are not allowed to put 1 first. Be careful. You have to differentiate first and then replace x with 1. So let us go to the board and I will do the same thing. So this is problem 3137, part B. So the function is given to be f of x equals to square root of x squared plus 3. And I want to calculate f prime of 1. So the first thing I have to calculate f prime itself. Then I know that this is not in my table, the same story. So I need to take something u. So this is a good choice for u. Do I know how to differentiate the square root of u? The answer is yes. It follows the same rule as if u is x. But then you have to multiply by u prime. So this means that f prime of x is equal to 1/2 square root of u, but u is this guy. And then you have to multiply it by the u prime. And I go one step more. Because the process is not finished yet, I have a prime left. This becomes 2x. And I prefer to write it more compactly because these 2 and 2 are gone, and I prefer to multiply the numerators. So f prime of x becomes simply x over square root of x squared plus 3. This is f prime of x. But what is needed is f prime of 1. It becomes 1 over square root of 1 to the power of 2 plus 3. So I replace every x in f prime by 1. It becomes 4. Square root of 4 is 2. So as you mentioned correctly, the answer is 1/2. Okay. So let us go to the next page now. Okay, so I want to wait for you a little bit. Okay, so I want you to solve these 3 problems, 3139, 3140 part B, and 3141. So that we have enough time to go to the more interesting problems. Okay? So let us wait for you. So in this problem, you're supposed to find the k value for this curve. Of course, curve is the function here. And here you want to see for which value of x the derivative is equal to 0. And usually, if you can do this one yourself, you want to differentiate this function, it means that you are on the safe side from understanding what the chain rule is. If I can make it a little bit bigger. No. Yes. Yes, this is good enough. Okay, so if you don't mind, let us start doing them because I want to go to more interesting problems. These are very simple problems, yes? So you want to find the slope of this curve at x equals to 1, so you know that you have to differentiate. But to differentiate this one, this is not the case that you immediately need the chain rule, yes? You need another rule prior to the chain rule. What that rule is? So if I want to solve that problem 31, 39, so I differentiate, but the derivative of the whole expression needs rule number 3 first. It is important to understand these things. Of course, in exam you can just do it directly, but let me try to emphasize that you really need 2 rules here. One rule is rule number 3, which tells you don't care about the constant, pull it out, and then multiply it by. This way of thinking is important if the question is a little bit harder. Now for this part, so I used rule number 3. But for this one, I see that this is not directly in my table, so I have to use the chain rule. So what is a good choice for you in this case? Yes? Hopefully everyone agrees this is a good choice for you. Yes? Because then the derivative of e of u I know, because this is similar to derivative of e to the power x. So I follow the same rule as if u is x, so it becomes the function repeats itself. But the problem is that this is not finished yet because I have to multiply it by the derivative of u. Any questions? Okay, but the process is not finished yet because still I have a prime left. The derivative of this is extremely simple, so it's minus 4x. And I prefer to multiply it. So finally, my derivative is equal to, I multiply that, it becomes 3.2 x e to power minus 2x squared. But that is not exactly what is wanted. What is wanted is the slope, and the point x equals to 1. The x-coordinate of the point of tangency is also given. So, if I want to find the slope, I would write the slope is equal to y prime, but at x equals to 1. So I replace x with 1, so it becomes minus 3.2 e to power minus 2. And I don't even bother to simplify it. That's the answer. You shouldn't, unless it is mentioned in the problem that you have to approximate it. So I'm using Swedish, I'm using English, so this is dot. Yeah, I mean decimal point, not multiplication. Is that correct? That was the first. Any questions here? Understandable? Did you make mistake or not? How many of you got the correct answer? That's good. So let us go to the next one. The next one is also very simple. You have enough experience of differentiating the square roots now. This is why I'm saying that it is extremely good to have this in your memory. This is not in the formulation. So here the problem is clear. I want to differentiate. After I found my derivative, I put it equal to 0. So problem 31 for the part B. I want to differentiate, and hopefully you agree with me. This is a good choice of u now. So square root of u follows the same rule as the square root of x, except that I have to multiply by u prime. So what happens? This becomes f prime of x equals to 1 over 2 square root of u, but u is that guy, and then multiplied by the derivative of u. So one more step. The process is not finished yet because you see prime left. Differentiation of this is extremely simple. It's just 2x plus 4. You can keep it like it, or I prefer to factor a 2 out. That 2 that I factor will cancel this 2. So eventually I have my simplified version of my derivative. So it becomes x plus 2, because when I factor 2 out, x and 2 are left. That 2 that I pull out, simplify that one. So I will have this. So this is the derivative. But the goal of this question is to find x for which f prime of x is equal to 0. So this means that I myself equate it with 0 and then try to find x. This is my derivative. I equate it to 0 by 0. So this becomes x plus 2 square root of x squared plus 4x plus 8. And I intend to choose x in a way that the answer becomes 0. That's also simple. It's a fraction. A fraction is 0 if and only if its numerator is 0. Of course, the denominator shouldn't be 0. But that's not a big problem here because this implies that x plus 2 is 0. This implies that x is minus 2. Yes? So that was also very simple. Finally, 3141. So I hope that you, before me, you could solve the problems correctly. So how many of you got the last one? So what is your suggestion for the last one? The last one might be a little bit tricky if you don't find the correct way of doing it. Do you have any idea what to do for the last one? So let me write it here. 3141. F of x is equal to 1 over square root of x plus x to the power of 4. Yes?
And expand the power 4 to the top and bottom, which means we can write it as the square root of x plus x to the power of
Yeah, exactly. So I will do this. That is, I think that's the best option. So it becomes square root of x plus x to the power of minus 4. I also prefer this. Might be some of you directly wanted to take this u. It's not a big problem right away. It's not a big problem if you manage it. So you take this u to the power 4, you can use that. And then of course, then multiplied by u prime, then you have to remember, you have to take the u prime. But u prime needs another u, yes? Or you can bring it up and make it another u. But this method, you just have one u and we are done. So I prefer this way, okay? Is that understandable for everyone that this can be written in this form? Yes. Okay, so then I will take this to be u. Is it good? Yes. Why? Because if I take that u, then I will have u to power minus 4. Do I know how to differentiate this? Yes, because I can pretend u to be x. Minus 4 goes down. And then 1 unit is subtracted from this, so it becomes minus 5. Now that instead of x I have u, I have to remember to multiply by u. Okay, so what happens? Minus 4u to power minus 5. U is that guy. But multiplied by u prime. Yes? The process is not finished because I have a prime left. If you don't mind, it was a positive power. I prefer to end up with positive powers. That is just subjective thing. So I keep minus 4 up there. I bring it back down again. It is not necessary. As far as you just want to take the derivative right. But then multiplied by the derivative of this combination. So first I use the chain rule, but for this one I am using the sum rule. And this derivative of square root of x, I have it directly in my table. So I don't need to take the u or something. So that becomes this. And then this becomes 1. Nothing that much, we can simplify. So I stop there. So that's my derivative. Yes? So that was also not that hard. If you don't mind, let me solve one of these. So problem 3143, but let us take, because you have enough experience of the square roots, you already know what to do. So let us solve one of these problems, okay? So I want to wait a little bit for you, not too much, okay? 2 or 3 minutes. You are supposed to determine an equation. I don't know why they say ekvationen. Yes, ekvationen means the equation. But that's wrong because you shouldn't say the equation. If I have y equals to x multiplied by 2, it becomes 2y equals to 2x. It's a different equation, but represents the same line. So in principle, you shouldn't say. You should say 1. Okay, so you're supposed to find an equation for the tangent line. Okay, so you know that for this is a very archetypical example. So I give you a function, I give you a point, and I ask you to write an equation for the tangent line. Yes, and the main problem is to differentiate, and then put the number in so that you can find the k value. Okay, so you remember, whenever you want to solve an equation for the tangent line, this formula is also in the formula sheet. This is better, I think. Okay, so this is the formula of an equation this is the formula for equation. It's an equation of a line which passes through the points with coordinates x0 and y0 and the k value k. In this problem, by reading the problem, you immediately realize that x0 is just 3. And then you need to find y0, you need to find k. But what is y0? How can I find y0? Yes? Into the function. Why? Because this point of tangency is not only on the tangent line, but also on the graph itself, on the graph of the function itself. So it means the coordinates should satisfy the equation. So this means that y0 that I am looking for is very simple. I just put my number into my function, yes? So it becomes 3 plus 3 to the power of 2. So this becomes 2 over 81. So putting this number directly into the function gives you y0. Giving this number, is it wrong? Yes. So it is what? 36, yes? Am I right now? And then it becomes 1 over 18, thank you. So now what happens? So you put 3 directly there, it gives you y0. You differentiate and put 3 there, it will give you k. So remember, this is always the case. But the main obstacle in front of us is to differentiate, which be careful. This is one of those problems math 3 students cannot solve. It's not reducible to what you know then. Okay? If it was like this, math 3 students could solve it by bringing it up only. Okay? Here the trick is to bring it up, but we couldn't solve it because that's x plus 3 to the power of minus 2. So that I told you the trick. So the trick is to bring this up so it becomes 2, and it becomes x plus 3 to the power of minus 2. Now, we are ready to differentiate. Then I don't want to disturb you with this constant. You know, the rule is to think in that way. Constant goes out. So I need rule number 3 or rule number 4. So, if I want to differentiate, this is a good choice for you. This is a good choice for you. Okay? Because u to power minus 2, I want to differentiate it. So if I want to differentiate it, this 2 is a constant, multiplicative constant. So according to rule number 3, I don't touch it. And then I have u to power minus 2, which becomes what? Minus 2 goes down, u to power 1 unit less. U is x plus 3 to the power of 1 unit less means 1 minus 3. But the problem is not finished, even though coincidentally it is finished. Why? Because you multiply by u prime. Yes? Because u prime is 1, even if you have forgotten, nothing strange will happen. But be careful. The correct way is to write this. But this is 1, so that's a coincidence. So if I simplify that, this becomes 1 minus 4, and I bring it down again. So f prime of x is finally minus 2 divided by x plus 3 to power 3. So it is interesting, yeah? So when you differentiate this, you get a negative sign with an extra power there. And now you want to find the k value. So the k value is f prime at that number given. It was 3 there, yes? So it becomes minus 2 divided by 3 plus 3 to the power of 3. 6 to power 3 is 216, and then I have a minus 2. I just simplify it, it becomes 1 over 108. This is my guess.
You forgot the constant 2. 2 times minus 2 is 4.
Oh, okay, thank you. I forgot this. Thank you very much. So it is 4. This is also 4. That is also 4. So this becomes minus 1 over 54. Thank you. Now everything is ready, put them there, yes? So this becomes y. This is important to write. Y minus y naught. So it is 1 minus 18. K value is minus 1 over 54. And then I have x minus x naught, which is, x minus 3. And I prefer to simplify. So I want to keep y on the left side. If you do this, it becomes minus 1 over 54x. This becomes plus 3 over 54, which is plus 1 over 18, plus 1 over 18, plus 1 over 9 finally. So that is what you have to write. Be careful. These kinds of problems, you have to write this as the final answer. Yes? Okay. So that was also some good questions, but let me go to the next one. We have 20 minutes. So if you don't mind, let me start. I will come back to those problems. I want to make sure that you can do the chain rule. So I want to solve this problem, and I want to give you 2 or 3 minutes, not that much more, so that I want to see if you can do it yourself. It's a good problem. You will see why. 3148. So this function is given. You want to find the exact value of f prime of 1. This is one of those problems that you feel why it's a good name for this theorem to call it the chain rule. Okay, any answers? What's the answer?
E to the power of square root of 2 divided by square root of 2.
Yes. Yes. So how is that the case? Let us do it together. If I want to differentiate it, again, let us review. This is not directly in my table. So far, there is only one rule that I know how to use, and that is the chain rule. Some students, this is the common mistake, they feel that take this one to be u. I want you to see that why this is not a good choice. If you take that one u, you are in trouble. Why? Because if you take that one u, if you go to scratch paper, then what do you have? You have this. Okay? But can I differentiate it? No. Because if I want to know how to differentiate it, in my table I should have this. But I don't have it. What I have is just e to power x. Yes?
But if you do it like this, can you write like f of u is equal to square root of u, then one more function, f of u is equal to e.
No, but what I'm saying that this choice of u is not real correct right now. Yes? Because if you take this one to be u, then you will have this function. This function is comparable with this function, which is absent in your table. Okay? So right away, this is not a good choice. So this is not working. So what is the option left?
Whole root.
The whole thing to be. Is it going to work? At least for the first step. Why? Because if I take the whole thing to be u, then I will have e to power u. The e to power u is comparable with e to power x, and e to power x is there. That's good. So I will start. So do I know the rule for e to power u? Yes, because I know the rule for e to power x. This is the same rule as it, but you have to multiply by u prime. You don't need to write these things. You can just do it in your head. So it becomes e to power u, but u was this guy, multiplied by u prime. Okay? But now to take this one, you need to use the chain rule, yes? But this time, that u which was not good is the only option that you have now, yes? So this u becomes this now. You see, choosing this to be u in the first step was not correct, but this is the only option that we have right now. Is it a good choice? Yes, because if I choose that one u, then I will have a square root of u, which is comparable to square root of x, and I have it in my table. Okay, so it means copy and paste whatever does not have primes, but the process will finish only if there is no prime left. So I will use the rule for a square root of x for a square root of u, but I need to remember to multiply by u prime. So it becomes 1 over 2 square root of what? X squared plus 1 multiplied by u prime. So now you feed this, why this is called the chain rule, because these derivatives are coming one after the other. So is it finished? No, because there is one prime left, so I continue. So continue means not being lazy, copy paste everything so far, and then go one step further. So why this happens? Because we have three functions involved here. X squared plus 1 is the innermost function, then a squaring root function, then exponentiating function. Okay? So this is my derivative. But I prefer to simplify as much as possible. That's subjective. So f prime of x is equal to, and 2 are gone. X will be multiplied here. That will also be multiplied there. So if you don't mind, let me write it more neatly as this, and then I have this. So this is finally my derivative. Yes? And now I want to answer my question mark. The question mark is f prime of 1. So I have to replace every appearance of x with 1. It becomes square root of 2, 1. So it becomes, as Simon mentioned, e to power square root of 2 divided by square root of 2. And we want the exact value. So that is the final answer. Yes.
So did we take the derivative of e to the power of square root of x to the power of 2 plus 1? Is it the same as itself, or?
No, don't get confused. That's the whole point of the chain rule. You see, you have to choose something for u. I told you that if you take this one u, then you will have e to power square root of u. E to power square root of u is comparable to e to power square root of x, but e to power square root of x is not in my table. So that is not a good choice. Then I said that, okay, let us take this one u. Then it becomes e to power u. E to power u is comparable to e to power x, and e to power x is in my table, so that's a good choice. But then when I come to this one, it seems that I am solving this problem. In this case, choosing this to be u is good, because it will become comparable to square root of x, and which is in my table. But that's the idea. Okay, and I want to go back now. These kinds of problems are also very interesting. We can design, of course, they have designed it a little bit naively. Not because they are naive, because the students are actually taking the simple route, and that is wrong. So this problem we want to solve, I solve the simple one, I leave the harder one for you, okay? And of course I will solve them later. So this type of questions, this is extremely important question. Determine with the help of the graphs in the following figure that h prime of 2 if h of x is f of g of x. So that's two problems. So let us think about them separately. Three graphs are given to you, red, blue, and yellowish. Remember, two of them are not the graph of the functions. This blue one is the graph of the function g of x. The yellow one is the graph of the derivative of g of x. And the red one is the derivative of f. We don't see the function f itself here at all. So some naive way of solving this problem is students start guessing. Okay, they say that, okay, the blue one is x squared. If you guess, and I know that, the answer becomes correct because the author also thought in that way. He didn't want to disturb himself to put something a little bit extraordinary there. So if you guess, your answer will be correct, but it will not be accepted for this problem. Okay? So you need to just use the information given, not just based on guess. Okay, so let us try to solve this problem. H of x is given to be f after g. I don't know f, I don't know g, I have some access to some part of the graph of those functions. I want to calculate h prime of 2. So let us go to the board here, and then I will come back. So, because there is no time, I will ask your opinion about it, but there is no time that I can wait for you to solve it. You can test your understanding in the second part, which is more interesting. So, the function h of x, so this is problem 3145, part A. So the function f is given to be f of g of x, and I am supposed to calculate h prime of 2 based on the information given on the picture. So forget about the picture. If I see this, there is only one way for me to do this.
This is 3146 and 3146.
Thank you. 3146, thank you. Okay, if I want to answer this question, there is one way. Differentiate h first and replace x with 2. So I will do the same thing. But when I want to differentiate h, what should I do? I have to use the chain rule. So it becomes f prime of g of x multiplied by g prime of x. Actually, it's nothing. Yes, I did just as the formula. But now the question mark is h prime of 2. So it means that I have to replace every appearance of x with 2. And that's it. The problem is not that hard, by the way. The second one is more interesting. And then I need to read what I need to read the information I need from the figure. So I need to answer what this question mark is. I need to answer what this question mark is. Multiply them, I will get my own question mark. But that is also easy, isn't it? Because if you want to answer what is g prime of 2, which graph you go and look at? The graph of g prime. Yes? So let us go to the picture. This is the graph, this one. Let us make it a little bit bigger, yes? So this is the graph of g prime. You see there is a prime up there. But my goal is to calculate g prime of 2. What does it mean? It means that, let me change my tool. Where is this? Tool, yes. So here, I want to know g prime of 2. You see, g prime of 2. So the x coordinate is 2. So I go, this is 1, this is 2. I go upward to see where I intersect the yellow curve, or the yellow line in this case, here. So what is that number? This is this number. What is that? 1, 2, 3, 4. So that was 4. Yes, so g prime of 2 is 4. So I go back to the board, g prime of 2 is 4. This is always, you learn this is not hard. This is two-step thing to do. One step is to calculate g2, and then the second step is to calculate f prime of what I got. So don't be in a hurry. F prime has to wait. By the way, this is also f prime after g, if you like. Yes? So f prime after g. So it waits for g. We go to the board. I need the graph of g because I want to answer what g of 2 is. Okay, so where 2 is again here. Then I consider the blue curve because that is the curve of g of x. So I go upward so that I can intersect. But the intersection point is again coincidentally the same point. So I go here. So what this point is again 4. Okay, so now it is a two-step task. So this is 4. But it is not finished because now I need f prime of 4. So I have to refer to the graph of f prime this time. So I go to the board. So f prime is this red line. But I need f prime of 4. So this is 1, this is 2, this is 3, this is 4. I go upward. I have my intersection here, sorry for the mess, and then I go horizontal. Okay, this is my point. What that point is? 1, 2, 3, 4, and 5. Am I right? Okay, go back to the board. So this is 5 times 4, so the answer is 20. This is the only way to solve this problem. So if you guess, even if your guess is correct, it is not accepted. It's not hard for me, by the way, try to find a function that you couldn't guess. Okay, so you need to learn. But the second one is very interesting. I don't want to spoil it, okay? I want you to think about it yourself. It's a better question. Okay, any questions? Okay, but be careful. This is very important. The next lesson you will not understand if you don't understand the chain rule. It's called the application of the chain rule. Okay, so you need to understand, have a deep understanding about this. So I really recommend you go back home and try to solve one of these problems that we left and we didn't solve. Okay, especially this problem, part B. Okay, any questions? Okay, have a nice weekend. Thank you.